Hello my friends, and welcome back to the Today Machine channel. Aula Special provides a reliable solution for transporting exceptionally wide and long cargo across Finland and Sweden. With impressive capabilities, Aula's special transport vehicles manage combinations up to 49 meters long, 7 meters wide, and nearly 7 meters high. Recently, Aula facilitated a special transport project from Kokkola to Pietarsaari in Finland for Nordpipe Composite Engineering Oy, navigating the cargo through the port of Pietarsaari. The journey then extended across the Baltic Sea to Sweden, landing at the port of Norrköping. From there, the transport made its way along the Gota Canal, reaching Linköping and ultimately Tekniska Verken, a prominent engineering company in the region. Aula's specialized transport solutions ensure the safe movement of large-scale and complex cargo. Like oversized industrial equipment and composite engineering structures, by leveraging their expertise and robust fleet, Aula Special successfully supports industrial projects requiring logistics planning, regulatory clearances, and technical coordination across international boundaries. In Noshiro City, Akita Prefecture at Kazenematsubara, Marusho Transport's wind turbine team recently transported a 43-meter-long wind turbine blade. Moving such a massive blade requires expert handling, as it passes through both urban areas and natural landscapes. Marusho Transport specializes in these challenging logistics, ensuring safe and efficient delivery of heavy and oversized wind turbine components to renewable energy sites across Japan. The team's experience and dedication are critical in supporting Japan's green energy projects. The Yuen Mobile Stage Trailer is a cost-effective solution for setting up stages quickly and reliably at outdoor events like concerts, elections, and crusades. Mounted on a truck or trailer, the stage can be fully unfolded or closed with minimal manual effort, as the hydraulic system enables these actions at the press of a button, enhancing both efficiency and convenience. Hydraulic operation. The hydraulic system controls both the unfolding and closing actions of the stage, making the setup process smooth, safe, and stable. A remote control panel provides easy operation with a wide field of vision for better precision. Automatic control. The stage is equipped with an automatic control system that handles the entire opening and closing process. This system ensures safety and speed, offering a compact, secure structure with reliable connections and positioning. The control system uses a safe, low-voltage District of Columbia 24V for added security. Adjustable ceiling height. The stage ceiling, once lifted, can reach a maximum height of 4.3 meters to 8 meters from the stage platform, adaptable to different event needs. This adjustable height provides versatility, accommodating various types of performances and visual setups. Hydraulic safety locks. Each hydraulic cylinder in the system is equipped with a hydraulic lock, providing self-locking protection in the case of accidental tubing damage, enhancing safety and system reliability. Precision lifting mechanism. The ceiling is lifted by a synchronized system of 4 hydraulic cylinders and 4 guide columns, achieving synchronization accuracy below 1%. Safety bolts on each guide post provide additional security during the performance, preventing any instability. portable and easy to transport. The trailer is designed to be towed by a standard 4x2 tractor, allowing it to be transported to events with ease. Performance-ready ceiling. The ceiling structure includes support for lighting, sound, and other equipment, offering strong load capacity to handle complex setups typical of concert or event staging. A scene from Tohoku Express shows a 23-meter sheet pile being transported to a work site on a pole trailer. The vehicle must make a right turn after first reversing, as it can't complete the turn in one go. The right rear wheel ends up just 5 centimeters from the curb. Close. This highlights the importance of a thorough site inspection beforehand for smooth, safe navigation. On May 30th, ALE undertook the monumental task of transporting a massive 475-ton transformer from the Alstom factory on Lichfield Road, Stafford, to its destination in Congleton, Cheshire. The operation began smoothly as the convoy set off from the Alstom facility, navigating Stafford streets with precision. However, as they reached the Weston Road roundabout in Stafford, the lead tractor, a Unipower, encountered unexpected gearbox issues. Engineers were able to perform a temporary repair on site, allowing the convoy to resume movement temporarily. However, as the journey progressed toward the A34 and Red Hill Island, it became clear that the Unipower was still struggling. In response, ALE deployed a Fawn tractor to stand by in case a replacement was necessary. Ultimately, the decision was made to replace the Unipower with the more reliable rear Trojan 8870 tractor, which moved forward to take the lead position. With the Trojan 8870 now in place as the lead tractor, the convoy continued along its route. The police escort, which had been accompanying the convoy from the start, played a crucial role in ensuring a smooth journey. At the Phillybrooks roundabout, they went ahead of the convoy to open the gates, facilitating an easier passage and avoiding any further delays. As they approached Newcastle-under-Lyme, the convoy moved through the Rycroft area, and then continued toward Congleton, passing through Padgebury Lane, Holmes Chapel Road, and Box Lane. The team's adaptability and the support from ALE's backup equipment allowed the convoy to overcome technical challenges without disrupting the overall schedule. The police escort's proactive assistance also helped mitigate any traffic impact along the route, ensuring a safe journey for both the transport team and the public. Despite the initial mechanical setbacks, the operation was a success. The disassembly and transportation of a large hydraulic truck crane requires specialized handling due to its size and weight. To move it, the crane is dismantled into 3 main sections, each of which is loaded onto separate large trucks for transportation. To facilitate this process, 2 additional cranes are brought in to assist with the disassembly. These cranes work in tandem, providing support and lifting capacity to safely separate and lower each segment of the crane onto the trucks. The added cranes help stabilize and handle the large parts, making it easier and safer to control the heavy components during the dismantling and loading phases. Once the hydraulic truck crane is divided into its 3 segments and securely loaded, each truck can independently transport its load to the destination, where the crane will be reassembled as needed. This approach is not only efficient but also essential for transporting massive equipment like hydraulic truck cranes, which, when fully assembled, would be too large and cumbersome to navigate standard roads and bridges safely. By breaking down the crane into sections, the disassembly and transport process ensures safety, compliance with transportation regulations, and minimizes risks during the journey. Cranes are designed to handle significant weights, with some capable of lifting loads over 1,000 tons. However, when lifting large machinery like a 20-ton excavator, the risks multiply due to the potential for mechanical failure, human error, and environmental factors. One significant risk is the crane's load capacity. If the crane's capacity is exceeded or close to its upper limit, it can lead to structural strain and, in severe cases, collapse. Even if a crane can technically lift the load, wind can add unexpected forces, making a load of 20 tons feel significantly heavier. Typically, lifting operations are avoided when wind speeds exceed 20 miles per hour, but gusts can be unpredictable and sudden. Another risk factor is human error, which contributes to almost 90% of crane-related accidents. Miscommunication or a minor calculation mistake in weight, balance, or load distribution can have catastrophic consequences. Rigging is critical to secure the equipment correctly, as even a slight imbalance can cause the load to slip or shift during lifting. Finally, weather is a constant threat. Rain and snow can make rigging slippery and reduce visibility, increasing the chance of accidents. Ensuring proper training, adhering to safety protocols, and monitoring environmental conditions are essential to mitigate these risks in lifting heavy equipment to high-rise construction sites. In snowy uphill terrain, a large trailer got stuck, unable to gain traction. Despite initial challenges with the differential lock, it finally engaged, allowing the GRJ-76 to attempt a tow. The Land Cruiser 70 bravely took on the rescue, creating a bit of a scene as others looked on, surprised. Even though a wheel loader was available, it wasn't needed. The trailer driver and the company offering the loader were astonished when the GRJ-76 successfully completed the challenging rescue. The transport and installation of a 160-ton transformer for a wind farm is a meticulous, multi-stage process requiring specialized heavy machinery and expertise. The operation begins at the port of Thessaloniki, where the transformer is loaded onto two 10-axle Goldhofer THP SL trailers using a ship crane. The next phase involves transporting the transformer from Thessaloniki to Giannitsa, a route filled with critical points such as narrow passages, sharp turns, and weight-limited bridges. Expert planning and precision driving are required to safely maneuver the convoy, which is powered by robust vehicles like the MAN T680 8x4, MA T660 8x4, and Volvo F520 8x4, all equipped with WSK torque converters to handle the heavy load and challenging terrain. Upon arrival in Giannitsa, preparations for the final leg to Vermio are set in motion. Here, a Liebherr LTM 1500 mobile crane, equipped with a substantial 135-ton counterweight, is assembled to lift and position the transformer. This crane's powerful lifting capabilities ensure that the transformer can be safely and accurately placed in its designated spot on the wind farm. The installation process is the culmination of intense logistical coordination, requiring skilled operators and specialized equipment. Setting up the crane on site and securely positioning the transformer in its final location demands careful alignment and a highly skilled team. This final step is critical to ensuring that the transformer will function effectively within the wind farm's infrastructure, supporting renewable energy production for years to come. The Tadano 250 all-terrain crane is a robust and versatile lifting machine that stands out for its adaptability across a variety of terrains and its ability to maneuver into confined spaces. Engineered to excel in both on- and off-road environments, the Tadano 250 is perfect for construction and industrial applications where access, flexibility, and high lifting capacity are essential. With a maximum lifting capacity of 250 tons at a radius of 2.5 meters and a tip height reaching 111 meters, this crane is well suited for projects requiring significant load bearing and reach. Key features and capabilities: highway speed mobility and off-road capability. One of the primary advantages of the Tadano 250 is its ability to travel on highways at speeds up to 85 kilometers per hour, thanks to its powerful Scania engine, which provides 405 kilowatts, 550 hydrogen phosphide of output. This speed allows it to move quickly between job sites, improving project efficiency. Off-road, its all-wheel drive and steering configuration, 10x6x10, with an optional 10x8x10, give it excellent traction and maneuverability over rough or uneven terrain, making it ideal for remote or confined job sites. Advanced boom and jib systems. The crane's boom can extend from 12.7 meters to a maximum of 70 meters, with a load radius reaching up to 78 meters. This flexibility allows operators to lift loads to substantial heights and at impressive distances. Making it suitable for a range of tasks, from heavy industrial lifts to precise placement in construction zones. Additionally, the auxiliary jib, referred to as the MAGO extension, offers further reach and versatility. Efficient setup with extendable outriggers. Stability is essential in heavy lifting applications, and the Tadano 250's extendable outriggers provide a reliable base for lifting. These outriggers can be extended and adjusted as needed, allowing the crane to be positioned securely on uneven ground, ensuring safety and reducing the risk of tipping during operations. The process of setting up the Tadano 250 involves extending the outriggers, raising the main boom, and, if required, extending the auxiliary jib. Once the jib is no longer needed, it can be stored efficiently, reducing setup and breakdown times and allowing the crane to be repositioned or transported quickly. Compact design for confined spaces. Despite its substantial lifting power, the Tadano 250 is compact, with an overall length of 14,490 millimeters. A width of 3,000 millimeters, and a height of 3,940 millimeters. Its design allows it to access confined job sites where larger cranes might struggle. The all-wheel steering enables tight turns and precise positioning, making it especially valuable in urban environments or areas with limited space. Practical applications. The Tadano 250 all-terrain crane's combination of highway travel speed, off-road capability, and lifting strength makes it ideal for diverse applications. In construction, it can handle large precast concrete sections, structural steel components, and even entire building sections. Its adaptability is equally beneficial for industrial maintenance and heavy equipment relocation, especially where terrain access is challenging. It seems surprising that such a narrow road could accommodate a large trailer, but with the multi-trailer linked steering, from Banshu Shoen Warehouse, even a 3,200mm dolly can be transported from a 6-meter wide road to a 4-meter wide road. Of course, skilled coordination between the driver and the rear steering operator is essential. This innovative setup enables smooth transport of equipment that would otherwise require steel plates and crawler-type excavators to reach the construction site. With the Banshu Shoen multi-trailer, these challenges can be overcome. Making it a highly efficient solution for transporting heavy machinery to narrow or difficult-to-access locations. It's a valuable option worth considering for industries that require reliable and precise transport in confined areas. At Sardargram Railway Station in Ahmedabad, a unique event recently caught attention. A tractor running on a railway track. This demonstration highlights the versatility of certain agricultural machinery, designed to be adapted for rail track usage in specific conditions. The tractor, modified with rail wheels, ran along the tracks as part of a test or showcase to explore alternative means of transportation in areas where traditional rail vehicles may not be readily accessible or for special logistical needs. This approach can help in transporting materials or goods across short distances, particularly in rural or remote areas where rail infrastructure could be better utilized for various purposes beyond conventional trains. Driving a truck with a low-floor steering TR, lowboy trailer, or a high-bed short trailer carrying heavy cranes or other equipment through Japan's narrow, winding roads and alleys presents unique challenges requiring skill, planning, and patience. Japan's infrastructure is known for narrow streets, steep inclines, and tight turns, especially in rural areas, older neighborhoods, and cities where buildings are close to the road. Here are key considerations and best practices for safely and efficiently navigating these roads with a heavy load. Pre-trip planning and route selection. Before setting out, detailed route planning is essential. Japan's roads often have height, weight, and width restrictions, and many older areas were not designed for large vehicles. Municipalities may have specific ordinances and traffic restrictions, so be sure to acquire any necessary permits and check for restrictions on carrying heavy or oversized loads. Plan for slower travel to account for the need to make wider turns or stop for oncoming traffic, particularly on winding roads where visibility can be low. Weight distribution and stability. With heavy loads like cranes, weight distribution is crucial. For a low-floor steering TR, the lower center of gravity helps maintain stability, but it's still essential to avoid sharp, sudden turns that can lead to trailer sway. Maneuvering through tight spaces. Low-floor trailers with steering capabilities are advantageous for tight turns because they can pivot better and have a smaller turning radius. When entering a turn, assess the angle and adjust your approach. Hugging the outer edge of a curve may be necessary to prevent the trailer from scraping against roadside barriers, buildings, or other structures. The Loco Locomobile, built on the sturdy Ural-Next chassis, is an innovative vehicle for railway and tram track construction and maintenance. It serves as a versatile alternative to traditional shunting locomotives in medium and light classes, capable of hauling up to 1,500 tons at speeds up to 80 kilometers per hour. Designed for shunting operations, cargo transportation, and emergency response, the Loco can also clear tracks of snow, debris, and overgrown vegetation, ensuring year-round usability. The Loco is a multi-purpose rail vehicle developed to streamline rail construction, repair of contact networks, and maintenance work. It is highly efficient for transporting repair crews, further enhancing its value as an essential support vehicle for rail infrastructure. Engineered by ENPO Vector, known for producing specialized equipment on KAMAZ and Ural chassis, the Loco adheres to modern environmental standards, emphasizing eco-friendly operation. Transporting a 24-meter T-beam on a narrow, winding road poses significant logistical challenges, especially when it requires complex maneuvers like jumping and sharp turns. The sheer length of the beam makes it prone to overhanging in tight spots, increasing the difficulty of safely navigating narrow, curved pathways. To ensure stability, specialized trailers and equipment are required to keep the beam balanced and secure. Every turn demands precise alignment, often requiring the trailer to jump or adjust its angle strategically to avoid obstacles and keep the beam within road boundaries. Loading this massive structure requires precision from the start. Once secured, the T-beam is escorted from the factory, a process that involves expert planning and coordination among team members. Nico Transportation manages this challenge with the aid of experienced drivers who carefully navigate the complexities of mountainous terrain.